Hello and welcome back to the Oxford MAT Livestream. It's 2 hours of maths questions solved live with your help watching at home, and I'm your host, Dr. James Munro, the admissions coordinator for Maths at Oxford. I've tried scripting an introduction but realised midway through that I don't like it very much. Hello everyone, how are you doing? There's some people joining us live in chat. Here they come. Reminder that you can be anonymous in Slido chat if you want to. There is a link on the Matt Live page and in the YouTube description. If you're watching live, say hi in chat. Let us know how your day is going. Let's see. So we've got Matthew in chat, and an anonymous person says hello. Oh, they're all out of order. There we go. Okay. There's George, and I can see Sophie, and anonymous person, and Rice Cooker Man. Right. Okay. Here's the plan. We're going to do past paper questions from 2022. Let's plan. Hello, Addy. And I think I can infer, yes, hi to Callie as well, who is moderating chat. I forgot to send Callie a link until just before we went live, so good to see that we've got Callie as well. Callie's a current student who will be moderating chat and also perhaps getting involved. And let's see, how are we doing? Yes, some people might have done tests for mathematics for university admissions. There's another admissions test. I hope that if you've been interested in both tests, that you found that you can do preparation for both of them at the same time. I hope that you found that useful and that you've enjoyed thinking about lots of tricky maths questions. Today is all about maths admissions test, which at the time of recording is in 2 weeks' time on Halloween, 31st of October 2024. Yes, somebody in chat wants to know if I'm related to Dr. Hugh Munro, who is no relation, but also involved in outreach at Oxford, and yes, I do get asked that a lot. Tell Hugh that I said hi. Right, there's a vote on the screen going on in Slido for how was your day. I usually draw attention to people who have voted low scores, but today I think I'm going to do shout out for people who are having a good day. If you voted for you're having a 5-star day, then hey, we've got some math questions coming up. Let's knock them out of the park. Let's just continue with that 5-star kind of feeling. And if you're having a terrible day, then I guess let's hit some things really hard and see if that makes things better or not. We have some sort of baseball metaphor going on there. I'm trying that out. Let's see what that's like. Good. There's a year 11 kid in chat who was in year 10 last time, so I guess they say they've now moved up a level. Yeah, Tamura, people are not happy about Tamura in chat. They're voting low score because of that. So sorry about that. Here's another one. I'm not involved in Tamura. I don't know why I'm apologising. I think I'm just sympathetic rather than apologetic. I can still say sorry for that, right? I can say sorry. Someone wants to know if I'm going to dress up for Halloween. You won't know because we're not doing one of these on Halloween because of the actual maths happening. Sure, maybe I will. I promise you can't help me to. Right, good. Okay, people are voting. This is the question in the thumbnail that I chose. Slightly misleading thumbnail. I summarised this as factorise n to the 4 plus 4, which is not quite what the math question says. The math question gives you a fact. The fact says it is the case that n to the 4 plus 1 is this. Wow, look at this. This is like difference of 2 squares, but cool. Extra terms. It is just difference of 2 squares, really, I suppose. From this, we may deduce, and then it says n to the 4 plus 4, which is irritating because n to the 4 plus 4 is not n to the 4 plus 1. So this question of how we're going to match that up. What are we going to do? Let's get suggestions in chat. The question says, gives us a fact about n to the 4 plus 1. We would like a fact about n to the 4 plus 4, right? I sort of strongly suspect that a similar fact is true because it's asking about primes, and this is a factorization, a times b or something. So, you know, if it factorizes, it's not prime. Seems like related concepts, right? Prime factorizing, is this thing prime? Similar to the thing we're given, but not quite. Right, let us... What are we going to do? We're going to stop the poll because that's happening, I think. Oh, yeah, okay. Oh, it's got a nice pleasing distribution. 4, 8, 20, 28, 40. That's quite nice, isn't it? Whoosh, upwards. Never seen it look like that before. Your test centre has slow computers and bad whiteboards. We will look into this. Yes, I was not expecting erasable pens. We will look into this. Okay, thanks for the heads up. Rough paper whiteboard distribution. Okay, thanks for letting me know. I will make some inquiries. Yash would like to add 3, which is fair enough, right? This plus 3, right? And then we've got this hard question, like, is this a prime number? We've got it factorised, but if you add 3 to both sides, you get this kind of factorised thing plus 3, so like AB plus 3, is that prime? Do you ever have a composite number? So A times B is composite, not prime. If you add 3 to it, do you get a prime number? I think maybe, like 8 plus 3 is 11 is an example where you get a prime number. 15 plus 3 is 18 is an example of a time that you don't. Let's tidy this up a bit. I've got my thoughts visualised on screen. Let's get some maths going. Addy's got a strategy which looks a bit magic to me, so I'd like to try and break that down. This looks like a more, here it comes in chat now. Change the 1 in each bracket to 2, then figure out what the root 2's changed to. I quite like that. I think that's a way in. If you accept that this fact is true, you might try and explore why. Why is this fact true? And there's a couple of things you might discover. You might read this as n squared plus 1 plus root 2n times n squared plus 1 minus root 2n, which is the difference of 2 squares that I was kind of referring to. And that might give you ideas about how this works. How you could maybe do something similar for n to the 4 plus 4 to write it as the difference of 2 squares, a bit like this. Or there's this approach where you just go, you know what, we're just going to throw in n squared plus 2 squared-ish, and then try and fix that. But that'll have roughly the right, it'll have the right n to the 4 bit, it'll have the right 4 on the end. There's a bit in the middle that we're not quite sure about, but you know, this is not just n to the 4 plus 4, but it's pretty close. There's a middle term. So there's some ideas for you. We can maybe adapt this and try and factorise this. We would desperately like to factorise this because then we would know that it's basically never prime. N has to be odd. That is a good observation. If n is even, then my suspicion is that n to the 4 plus 4 looks very large and looks very even. Probably not a prime number. So yes, at least you can say that n probably has to be odd. I'm hedging my bets in case there's any small counterexamples that we should worry about. You know, like how there is an even prime number, 2 is an even prime number. Actually, I think 4 is larger than 2, so maybe I don't even need to say that. Okay, so maybe it's a prime number for, I don't know though. So it could be some of the odd numbers, right? All of these sort of seem like they're in play at the moment. Well, it might be never, right? It might be the case that I don't think you can say. I know that n has to be odd, therefore it sometimes happens. No, right? I mean, it could never happen, and you could still say we've ruled out the even numbers. Is all we can say so far. And I think that's the best way of rephrasing this thing that's been put in chat, that n is not even. Of course, it might still turn out that n is not odd either, in which case, no explosions. Yeah, I guess that does tell you that n to the 4 plus 1 has to be even. I think rather than going for literally this thing plus 3, which is the obvious link between these statements, the problem is that adding 3 doesn't give you a nice fact about factorising. So I sort of scribbled that at one point. I had a plus 3 over here, but I just couldn't see any way to make that into a similar factorisation thing. Let's multiply out this. So because this is actually quite close, isn't it? It's something like this. So it's n to the 4 plus 4n squared plus 4, which is close. So this is my observation. The things that I write on the screen are a mix of what I would actually write on a scrap of rough paper or a whiteboard or whatever, mixed with stuff that I'm thinking. That's not normally how people write stuff, just to be clear. Anna is checking small numbers. If you put in n equals 1, then you do get a prime number. So this does sometimes happen. Right, is this why people are saying not A in chat? I see, sorry, anonymous person who said so not A, question mark. I wasn't sure what you were referring to. But yes, you've put 1 plus 4 is 5. Welcome to the MAT Livestream. 1 plus 4 is 5 is prime. Hooray! We've discovered a prime. So it's not A. It's not never. Oh, brilliant. Not never. I guess the question now is that the only example, or are there any more? Shall we check? We've decided that n shouldn't be even. We should probably check like 3 to the 4 plus 4. Oh my goodness, that's 3, 9, 27, 81, 85 is not prime. And then I suppose the next one I should check is 5 to the 4 plus 4. But oh my goodness, 5, 25, 125, 65, 629. I just don't know if that's prime or not. It's not multiple to 3, but oh, I don't know that many primes. Tricky. What have we got? Add and subtract 4n squared. Yes, okay, so here is a 4n squared. I think it's come quite naturally out of this idea that it's almost n squared plus 2 squared that we're being asked about. Here's a 4n squared. So what we want, we can write down this kind of true statement that it's this minus this 4n squared that we didn't want from the middle. Kind of the dream that you could square this just by squaring each of the terms. You get this middle term, which we should subtract. I want to write an equals here. Yeah, cancel it out. Oh yeah, so the people are cancelling out the root 2's. Great stuff. Love it. You're doing this slightly different route where you go in here with, I'm going to use a different colour pen, but you go in here and you sort of mess with these and you try like 3 here and 2 here and you say, well, it's probably the same sort of pattern, right? And there's even an approach where you write down something like this, n squared minus an plus b. You say, well, I don't know what these numbers are going to be. I'm going to call them a and b, and then try to just multiply this out and see what happens. Compare the coefficients. Some of these methods are a little bit like working backwards from the result that we're aiming for, and some of them are like working forwards from what is true. Down the bottom here I have something that is true. And up here something that kind of could be true if we choose A and B carefully. So difference of 2 squares follows through to give us this fact, which people with the alternative approach will be probably looking at now as well. I'm going to phrase it like this with the anonymous person. I'm agreeing with you, but I've put the 2 n's in the middle to compare it with the purple text approach. Yeah. So 4 to the 1/4 m. I'm waving my hands like this because warning. We're looking for positive whole numbers n, and then there's going to be, oh gosh, crikey, is that a positive whole number? Who knows? 4 to the quarter. Who can say? Yeah. So now looks not prime. The word for that is composite or something, but I'm going to say not prime just in case. Unless this is not prime, unless ... maybe one of these things is the number 1. Even primes are allowed to factorise like that. Sorry, odd primes are allowed to factorise like that. And the even prime is allowed to factorise like that as well. So we've got kind of 2 sub-questions here. And when I say is, is there a value of n such that, I know these quadratic is true, but probably this one factorises nicely, and this one I think doesn't factorise nicely. Or is it n plus 1 squared is 1? I think so. We're looking at n is 1 or negative 1, which is negative 1 is not a positive whole number. So I think this is the only case. What's 629 a multiple of that? Well, we can work it out because that's n is 5, so it should be 37 multiplied by 25 take 10 is 15 times 17. It doesn't seem very likely, does it? But let's check. This is a check, I suppose. Check n equals 5. Up here, I don't know if that's prime or not. So we've got 37 times 17. Just to check it quickly, I get 259. There's a comment on one of these YouTube videos has a comment that says that I multiply funny, but yeah, okay, so this is not prime. It's 37 times 17. Not something that I would have realised from looking at the number. And oh gosh, the smallest prime factor there is quite large, 17. But now that we've got this factorisation, aha, I can see that's not prime. And in fact, none of the rest of these are prime. Yes, this inequality, this identity is, well, something you might see as a cool fact, but whether or not you've seen it before, here it is in the question, and then adapting it is the thing. Okay, yes, equate each to one. There are two factors. Yes, one of them, yes, you could decide one of these must be equal to the number itself as a valid approach. So I could write on the right hand side, is one of these the number itself? On the right hand side here and here, I could write out n to the 4 plus 4 to test whether the factor is equal to the number itself. From past experience, I found that it's usually simpler to argue about whether or not the factor is 1. And you don't lose any cases like that, of course, because if one of the factors is the number itself, then the other one is 1. So as long as you check both factors to check their oneness, then you've captured the cases of this thing actually being a prime number. There is, by the way, there's a kind of trick here where it could be the case that there are some solutions for n, but then weirdly, despite one of the brackets being the number 1, it could still be the case that the other bracket is not prime. It's sort of weird. All the way through this, it's sort of true that prime numbers, you can write them as 1 times p. And it's also true for composite numbers that you can write them as 1 times itself. So if we were trying to find some more primes, and if it were the case that down here, like we've got n equals 1, if we're looking for primes, we should still check down here that 1 to the 4 plus 4 is prime. Nothing down here, sorry, just off the screen. Nothing down here is actually guaranteed that the other bracket is a prime number. We've just checked that it's not been disqualified as being prime. How do we get to n squared plus 2n plus 2 is plus equals 1? Oh, sorry, yeah, that's me accelerating. Intermediate line, let me zoom in. In my defense, I'd just done this one where I'd subtracted 1 from both sides or something. I'd sort of completed the square over here, look. I've just done this one where I completed the square and realised that I needed to add 1. This got 2 solutions. Am I an idiot? Is it also 0? Oh, there you go. That's a good example as well. I was going too fast. There's 2 solutions. But then this thing is 4, which is not prime. Oh, I missed a solution. Sorry, anyway, in my defense, I've just done the completing the square thing over here, where it's n minus 1 squared, but then it says 2. It says 2 instead of the expected 1, so there. Over here, I was reading this and just recognizing that this is pretty much n squared plus 2n plus 1. N squared plus 2n plus 1 is a thing that I've seen loads of times. I don't even know if I'm completing the square or not, but it's just so close to n squared plus 2n plus 1 that I wrote down this and then tried to correct the stuff to make it work. Did I get it wrong? It's possible that I got it wrong. Yes, I think I did get it wrong. I did get it wrong, didn't I? Because I should have subtracted 1. This should be 0. Thanks for the correction. Oh, I love this live stream. I never know whether I'm being politely corrected or being, asked for a clarification. And half the time I launch into this kind of like, thanks for asking. Let me explain, and then realise that no, I'm just being politely corrected. Thank you, Yanni. Hi, Hamza. Welcome to the show. We're doing MAT questions from 2022. We're about to switch on the vote for which question we're doing next. Just a quick look at questions on screen. There's some logarithms around here. There's some basic probability. We can talk about probability on the MAT if you like. We haven't talked about probability on the MAT for a while, so if you want to talk about that again, we can talk. And there's this sort of question about equations and roots, which is a bit like that. The long questions in 2022 had this kind of number theory thing, looking for positive whole number solutions to an equation. There was a question about integration. There was a question about drawing graphs, and including drawing quite a complicated graph by the end. It's choosing doors for a game theory, game show kind of situation, using strategies to win the game. Question 6 was about networks, and things changing over time and eventually stabilising or not. And question 7 had numbers being added to a channel popped off both ends. No, they're being pushed in both ends, but only popped off the right. Data science sort of thing. We can talk about whatever you like, but we're going to use some democracy. I think I've set this up right. It's an untitled. Let's put the question in. Or next. Let's go. Always fully prepared for what's going on. Somebody says, can I get ready for MAT in 2 weeks? Sort of hope so. Callie agrees. Technically speaking, you should probably know most of the syllabus already. So you've already been getting ready for the MAT. That's me, sorry, adding that on. Work hard, but avoid burnout. There are some past paper questions. That's what we're doing now. Past paper questions. And people are currently voting for, oh gosh, what are we going to do? What are we going to do next? Currently looks like question 2 is voting. I'm going to put that on screen. If you want to talk about question 2, here we are. If you don't, then democracy. Right, good. Would I recommend spending more time practicing multiple choice or long answer questions, as multiple choice is now worth more marks? The thing is that the topics are not changing. So the kind of format of how you answer questions and how many marks you get for different styles of question, that's a thing. But I think the thing you should be practicing is not specifically, multiple choiceness, but the thing you're practicing is solving things, of getting familiar with unfamiliar situations. The skills that you're actually working on are a bit more general than just what's multiple choice like. If this was the driving test, and I know the driving test in the UK at least has some like reaction time test and some other like recognising road sign tests, and if they changed that, then you could say, well, I should practice my reaction times or something. But multiple choice and long questions are not as different skill sets as that. At the end of the day, it's all maths questions. Yash hated this question when doing the question, but loved the solution. So here we go. By the way, you can look at the questions beforehand, of course. These are just past MAT papers that are on our website, and there are also worked solutions there. I can't remember if we made a video for this one or not. I'm not sure we did, but there might be some videos out there of somebody talking about questions. Is getting familiar with unfamiliar situation contradict? Yeah, I said that and realised that it was a bit of a tautology. I sort of regret saying it, but I'm going to try and stick to it. That you can't really get familiar with unfamiliar situations. That's what unfamiliar situations are. It's unfamiliar. But yeah, maybe 2 always wins. It's kind of sad for Sophie says it's sad for the other numbers. Fair enough, I guess. I like doing question 2. I think it's a good thing to do on the live stream. What I'm going to do, just looking at chat a little bit, let's switch this off. We are going to do question 2, and the questions are voting in order. What we're going to do, so somebody says it makes you feel dumb looking at the solution. So I think I'm going to try and counter that a little bit. We're going to do question 2, but we're going to try and talk more about how you might have the ideas. There's this web solution document that details what the ideas are or what you can do on each step. But I think maybe we can talk about how you have ideas. Does that make sense? So if you've already done this question at home, I'd like you to think about how you realised what to do next. Like, how did you make progress? Not exactly what you did, which is fine, we're going to go through the question. But let's think about how you got unstuck. Maybe you weren't stuck, maybe it was just obviously what you do, in which case I guess you could let us know in chat. But let's try and focus on what you were doing. 2 is the first prime. Yes, not a hot take. Is that part of this question? Anyway, okay. English says is that Pell's equation, which is an example of something you might think when you look at this. You might think, aha, Pell's equation. If you recognise this as Pell's equation, then wow, you've seen some maths that's not on the syllabus. Your reaction to that is probably, I'm not expected to know about Pell's equation, so this must be this must be a question that's based on Pell's equation, but using MAT-style mathematics. You might also think, Pell's equation is extremely hard. What on earth is going to happen in this question? And if you've not seen that equation before, then you're like me. Yeah, crikey, look at this. It's like difference of two squares, except 19 is not a square number. Oh, spoilers for the later part of the question, I guess, but I just love difference of two squares. If I see a minus sign and a squared symbol, I'm like, maybe it's difference of two squares. Shame that 19 is not a square number. Okay, what are we doing? If someone in chat just says difference of two squares for part I, 19 is not square, or maybe they mean z squared. Ooh, z squared is a square number. Maybe we can rearrange this. I hadn't thought of that. Ooh, maybe. Yeah, I'm excited. Factor it to what they gave us. Yeah, okay. This is good. People are giving ideas about how you might get started. A little bit of what you would do. A little bit of what you would do. A little bit of how you would adapt it. Yeah, okay. How you would adapt the first part to the later equations, and it does develop, doesn't it? So there's a there's this first sequence of parts about the number 19, which you're asked to do quite a lot of work about. Quite a lot of work on, and then there's a couple of new equations. This is one of those style of questions where you do some stuff, and then later part of the question is kind of do it again with no guide for else. If you don't know what to do, just factorize out all the brackets. Oh, lost connection, restored connection. Sorry if I disappeared for a second. Just squared the original for z squared. Yeah. That's amazing. Two people simultaneously say, I just squared. Wow. In sync. There's a third. Where were we using the word? Well, okay, right, good. Just square it. Yeah, I like that. And I suppose there's a way that you see a z, you see a z squared. Maybe let's get squaring in here. That let us down a little bit. That way of thinking let us down a little bit on the previous question we looked at, of course, where your first reaction might be, let's just try adding 3, and that didn't really go anywhere. Or for me at least, it didn't really go anywhere. Reminder that if you have an idea and it's not going anywhere, it's okay to go back and try and do something different. In a normal test like A-level, that might be a symptom of you making a mistake or not knowing the right thing to do. But on MAT, that's kind of normal. The questions are weird, unfamiliar. You might not know what to do. You might not have the the idea that completes the question immediately. You might have some other ideas first. Okay, what are we doing? Squaring both sides. Loss for the later parts. Yeah, I think that's normal experience as well. The earlier parts often have more concrete steps, and the later parts tend to test your understanding. The only thing you can really do there is to sort of stop, look back at what happened before, and try to repeat stuff as much as possible. When it stops working, try to work out how you can, without doing too much work, adapt it and change it. We're going to do that later on. Since the final two questions are typed, will the questions require rigorous calculations? MAT candidates, for the long questions, you are not expected to type complex mathematical expressions. I mean, you may infer that you are not expected to type words that describe complex calculations, because that would also be mad. The questions, for these long questions, you should expect to explain and justify your answers. Yeah, the 2xy, doesn't it? Which looks very squarey, doesn't it? Should we get on and square it? It's such a 4x squared y squared thing, which really feels like a kind of squaring situation, doesn't it? That's a good observation as well, Anonymous. Thank you for why this looks like something's been squared. There's many reasons to suggest things being squared. Let's go then. So if we square it, exploration now. I don't know that I'm going to get exactly the thing down there. Why have I written this like this? I'm doing my best. Oh my matrix. I don't know I'm going to get exactly this thing, but I'm going to get something that says z squared on the right, and at least, my rule of thumb, at least some of it looks like the stuff I wanted. So this 19 times 2 times x squared times y squared. Well, I think I wanted 4, didn't I? Because this says 4x squared y squared. So there's something not quite right. Or, well, I haven't looked over here yet either, have I? Let's multiply this out. I have to determine n, you see, and at the moment it's buried inside this square. So I kind of think this looks a bit like that, but not quite. And I'm thinking that x to the 4 looks a bit like what I'll get when I square up this. Y to the 4 looks like it might have come to here. I'm sort of suspecting that n might be 19 already because, well, I can sort of see when I square this out I'm going to get a 19 squared. Oh, I could write 361 here, but I think I'm going to leave it as 19 squared just for a moment. I can't see anything coming up immediately which is going to require like the number 361. So in terms of my comparison, I think it's easier to leave it as 19 squared for now. Anyway, let's multiply out this thing as well. Yeah, it's a plus b squared minus 4ab. Yeah, there's a difference of two squares thing going on. I do like the suggestion, if you move the z squared on the left and move this 19 thing on the right, then maybe you've got a difference of two squares thing going on. I do like that. I've opted for this method, but other methods are available, and yes, they do get marks. Okay, very positive feeling about this now, because the x to the 4 has turned up, and so has this n to the 4, n squared y to the 4. So this is matches, I'm going to just say matches if n is 19. And just to check that that is actually true, I've got 2 times 19 x squared y squared. Oh, lost connection, regained connection. Thank you, Myro. Minus 4 times. Yeah, so minus 4ab if you're playing along with that version. Really does equal minus 2 times 19 x squared y squared. And if I was writing something in a text box, I would explain about how I've multiplied at both sides. Some substitution. Yeah, 2n is minus 38. Seems likely. You should probably also check that the n squared thing matches up with 19 squared. I came at it from that angle. 2n equals minus 38 person in chat. You've come at it from kind of the other angle. Fair enough. Expand and compare. So probably the web solution just says something like expand and compare. But when you're actually doing the question, your thought process is perhaps something a bit more like there's some squaring going on. I will get an x to the 4 if I square this. I will get a z squared if I square this. I'm going to take the plunge and try squaring. Oh my goodness, I've got loads of terms. Let's do some comparing now. These two ideas come quite separately, I think. You might have the idea to expand and then realise that you can compare all of the terms. You might kind of compare first and realise, I should probably expand to make this comparison easier. But there's kind of two ideas. Okay, that's part one, but done in a kind of style where we try to talk about how we had the ideas. Thank you very much, chat, for helping out. Yeah, it'll all match up. So I think the web solution probably just says something like 19. How would you solve this if you weren't allowed to use the given form? Well, if you're not allowed to use the given form, then I think I would do a kind of... If you're not allowed to use the given... Well, I mean... I've reversed all my working. Reverse all my working. All the steps are reversible, so you can't prove that I've used the given form. Right. I would just say, and then this is equal to the statement in the question because all coefficients match up. That's just true the other way around as well. I've met people they're taught in school that you're not allowed to use the form of the answer, which is, I think, just misleading people, but it depends what you've been told precisely. For example, if you're asked to show that 17 is a prime number, are you allowed to use your knowledge of what a prime number is, or do you have to start with 17 and then do operations on it until it turns into a prime number? Are you allowed to use kind of what you know about primes? Yeah, obviously you are, by the way. That's a silly example, but sometimes I've seen people approaching maths like that, where they say, well, I'm not allowed to assume anything about primes. And you think, well, no, you really are. You know about primes. Okay, anyway. Of course, almost impossible to prove that 17 is prime without using the definition of a prime number. Right, okay, that was quite a long tangent based on something someone said in chat. Let's go for it. Okay, find Z. Oh, right, gosh, okay, find Z. Where was Z? Oh, it's up here, isn't it? Find Z up here. I've scribbled on it so much that genuinely a puzzle word search. Single letter word search. Brought to you by Oxford. Find Z. Here it is. X squared minus 19y squared. Oh my goodness. Okay, off I go then. I'm going to do x squared minus 19 times 9. I'm trying to remember if I wrote this question, you know. I think I might have. Which is then embarrassing that I can't really do it. Minus 2. Okay. Oh, hence find a pair of numbers with this thing equal to 4 and with x greater than 2. Okay, so do we have any ideas about how to get... I've got an example. Z is minus 2. 169 minus 19 times 9 is... Have I multiplied that correctly? 90 plus 81 is 171. Live arithmetic. It's why you came here, isn't it? So what are we doing? 2n is equal to 38. N squared is 361. Positive 361. Anonymous person with your 38 argument in chat at the top there. Try remultiplying things out. Yeah, so this is minus 2 squared. 4 is minus 2 squared. That's, I think, the right level of thing to spot. Just a tiny clue that's saying there's something in this direction, isn't there? We just had this previous part talking about z squared. It says hence, so using this thing you've just done. Hence always means using the thing that you've just done. And we have z is minus 2, and z squared is 4. So if I just plug these numbers in, if I just substitute these into this expression, I will get 4 on the right hand side. Not obvious to me what I'll get on the left hand side. If I really squint, and I've scribbled on it so much, just going to tidy this up, sorry. If I really squint, so much mess, I'm so sorry, that it is of the form square minus 19 times square. But I don't think I really spot that. I think I just get on with it and sub in some numbers. And it turns out that if you follow that through, substitute it into this equation, right? We had this thing in part 1, just use it. So if you plug that in, then you get humongous numbers, definitely larger than 2, by the way, but you get humongous numbers and 4 on the right hand side. And at that point, you don't care what the arithmetic was in part 1, you're just like, we've put in some numbers and we've got horrible square and another one with a 19 at the front. The trick there, where you're plugging in the numbers, I suppose, is to not square this bracket, but just to write down the value squared. So the same sort of thing as part 1 where I wrote down 19 squared. This is my intuition that squaring large numbers is work, and I will only do it if I feel like I have to. And in this case, I would like to have it in the form of x squared at the end, so that's much easier to say what the value of x is if I haven't already squared. Right, how do you get ideas to make questions? You look at maths wherever you can find it, and try to mess around with it and explore a little bit, and then try to write questions that prompt people to go on the same exploration journey that you went on, and if you do it right, then you end up with people going on a kind of journey of exploration based on a topic that you found somewhere. I'm pretty sure I had is this one of mine? I'm really sorry if you're watching this and this was your question. I think I had the idea for this based on seeing this equation and then trying to... This is a identity. Is it Brahma? Let's give her credit. Brahma Is it Brahmagupra's identity or something? Not that anyone has heard of this, but I think it's Brahmagupra's identity or something. There's a bit of maths that I found. Messed around with it a bit, and here's a question that's based on messing around with the same thing. But that kind of spirit of exploring something. Maybe you've done this with your favourite bit of maths or something you did for an essay or something, or some school presentation or whatever. Maybe you found a bit of maths and messed around with it a bit. Sometimes that's a good way to write questions. Right, good. That was for one person who wanted to know how we make the things. Right. What am I doing? Oh, I should probably actually do this calculation, shouldn't I? I should probably actually do x squared plus 19y squared, which is something like 169 plus 171. That's not too bad. There's a plus sign here. This is 19 at this stage. So I think I want 169. Oh gosh, I'm really running out of blank space. Sorry, 169 plus 171 squared minus 19 times and then 2xy. So xy is not too bad. It's 39 times 2 is 78 squared is 4. So what have we got? We've got 340 squared minus 19 times 78 squared is 4. So there's a hence here again, which again means referring back to the previous thing we did, which right now is this. So I've finally gone and squared the numbers, right, to work out x squared plus ny squared up here, and to work out 2xy. And I can't even verify this because I can't square numbers that large. I mean, I probably could if I had 20 minutes, but that's not. So then, yeah. Ideas then. How do we get from this thing, where we've got, it's a hence, so it means look at the previous thing, we've got thing squared minus 19 times other thing squared is 4. We would like x squared minus 19y squared is 1. And then there's a bit of an open-ended bit of question. Is this the only such pair? Justify your answer. Questions about primes. Should we do research on prime numbers and stuff? I mean, it doesn't hurt to look at stuff, does it? I don't think that's an optimal way to prepare for maths admissions tests, but I think it is good practice for being a mathematician. So maybe after the MAT, after admissions tests are out of the way, if you want to do some research on prime numbers and look up stuff, then yeah. Why are they important? Well, they're the building blocks of the integers, aren't they? The way that multiplication works on a fundamental level, I suppose. It's a bit like having the periodic table of elements, right? It turns out that everything's made of these. Let's try and understand them, because then we have some way to understand everything else as well. Yeah, so Anonymous wants to divide. Can we explain why we're dividing? Ooh, can we set these equal as they're both 1? Is z 1? I guess you could, if z is 1, if you've got, so I think you're slightly ahead of me, Anonymous, if you're slightly ahead of me, if you've got some example where that thing is 1, then sure, you could set it equal, I suppose. Z squared would also be 1, so you could have, yeah, some new expression, couldn't you, with these things in. Who knows what these are, but you could write something else would also be equal to 1. I suppose that's talking about this only such pair down here. I think Anonymous is down here. Oh, how did I get 78 and 340, says chat, before we divide them by 2, which is what I'm going to do. How did I get these? So 78 and 340 is what you get in here if you take these values of x and y, 13 and 3, and you just plug them in. So you multiply them and double, you get 78, and you do this stuff over here and you get 340. And then the crucial insight from doing part 1 of the question is that we do not need to calculate that. We know that it's equal to z squared, where z is this number, minus 2 in this case. So it's got sort of a shortcut for saying, well, if you plug in x and y, then you're going to get humongous numbers over here, but don't worry, we've got some insight into what the right hand side is. It's just z squared, where z is the value of this. So we plugged in the values of x and y they gave us, and we got some expression, 340 squared minus 19 times, whoa, that's 78 squared is 4. And now we'd like something with 1 on the right-hand side, but well, 1 is just 4, I guess, divided by 4 as a link. I guess it's also 4 take away 3, but trying to keep the same shape of equation. Divide by 4 is a good idea here. Dividing both sides by 4, because dividing by 4 has something to do with square numbers. 4 is square. The things on the left hand side involve these even squares, which is nice because when you've got even squares, there's a factor of 2 in each of those even numbers, which becomes a factor of 4 in the squares. We can divide both sides by 4 quite nicely, and that'll give us 1 on the right hand side. So something like 170 squared minus 19 times 78 squared is 1. Worth checking, because that looks mad, right? There's no way we could do that before we started this question, but Brahmagutra's method does give us this pretty cool solution for these. I didn't divide 78 by 2. I should write 39 here. Oh, it's the details, isn't it? Right, okay, and then we've got suggestions in chat. Divide by 2, it's 2 squared is 4. Yes. Good. Can you substitute x squared equals 1 plus 19y squared to the equation in part I? I guess you can, yes. I think you can. Yeah, that will give you something like huge number squared minus 19 times even larger number squared or something equals 1 on the right hand side. Seems plausible. Yeah, I like it. You can do a variety of different things. The answer to this next part is no, I can make another. I think the easiest way to make another is to say, oh ho, I now have a solution where z is 1. Previously we took minus 2 and squared it to make 4. Now I intend to take 1 and square it to make 1. So sort of do the same operation to plug in these values of x and y. Don't actually calculate them, but just say, well, we could calculate, right? 170 squared plus 19 times 39 squared. We could run this again. That's a step of the question to sort of check your understanding. Understanding that we can take x, y and generate a solution with z squared on the right hand side, which is 1 here. That's the kind of punchline. Underneath chat, sorry, but the punchline underneath chat is that's 1 again in this case. So it's a new solution to the same equation, which is kind of nice. But the element of what we're using from before is not really precisely the equations or precisely the numbers on screen. We're using this kind of idea that if you have x and y that do this, then you can make massive numbers that do that. You can kind of take the numbers from here and plug them in here. That's the operation that we're doing in part 2. Not the numbers from part 2, not the kind of punchline of part 2, but the operation to take something that does this and make something that does that. And what's more like being a mathematician than taking something and making something? I'll say, you give me this, I will give you back something else. Is that like being a mathematician? I'm not sure. Substitute it in, turn it around, flip it. You know, maybe go on this journey again, square it again or something. Make 16 on the right hand side and then hope that you get multiples of 16 on the left hand side. Good fun. Right, last 2 parts of the question. Sometimes the last parts of the questions like this will make you do something similar. So like part 5 wants you to find a pair of solutions like this to this equation. So part 5 wants you to kind of do it all again with the number 17. And sometimes the later parts of the question have an extra sort of small bit. We saw this last week when we looked at a question about logarithms where we did lots of work. We did some of the work again, and then there was a small part at the end which was just like, ooh, by the way, which of these numbers is larger? And that was 2021. Up here. So we do all this stuff with logarithms, and then we had, at the end, which of these is larger? A kind of slightly different sort of question. the technical term for that is a rider, I think, that you have the main body of the question and there's something else riding along for fun. In this question, it's the other way around. Part 5 is related, like strongly related. And part 4 is a kind of slightly different rider. It is now the difference of two squares. And if we want to do solutions to this, then we've got two things that multiply to give 1. There's really only a couple of cases. Maybe they're both the number 1, maybe they're both the number -1. That's kind of it. There's sort of not very many ways to do that if you want the difference of these two squares to be the number 1. Said differently, this says x squared is 25y squared, so 5y all squared in disguise plus 1. That x squared is a square number that's 1 more than this square number. That's ridiculous, right? The square numbers don't come 2 in a row, they come with big gaps between them. Oh, except for 0 squared and 1 squared. They're next to each other, they're consecutive, but that never happens again. The difference of two squares tells you that this almost never happens. Good, you need to check if those are reciprocals. We're dealing with whole numbers. So simpler thing is to just check these are factors of the number 1. So I would check, are these things the number 1 or -1? 1 has not got very many factors. I think I'd probably point at x plus 5y. Is that 1? Is that -1? Maybe I would solve simultaneous equations actually. Sorry, maybe I do want 2 equations. Previously we had a case, well, actually quite a similar question, wasn't it? Where we had a bracket and we were considering whether it was the number 1 or not. It's got 2 variables, x and y in here. I think I'll probably start adding things together. Yeah, check if they're plus and -1. I'd probably look at both of them at the same time here because I've got 2 variables and I want to do simultaneous equations. But maybe you notice that I had that idea after writing this and being a bit unsatisfied with what I've got. This looks hard. It's just 1. Can't be reciprocals as they're whole numbers. Since x is greater than 1. Oh yes, we've been told that x is greater than 1. That does look true, doesn't it? Yeah, okay. Yeah, probably that's good enough. You've got to, you know that you're trying to say there are no solutions to this. So make sure you say something that is actually true as well as leads to that conclusion, but we're going to be good. Yes, oh, y equals 0 works, but we've been told that x is larger than 1, so that is important. Okay. Last part of the question, and this is the one that I say is closely related because, well, look at this pink underlined thing. X squared minus 19y squared is 1. Down here, x squared minus 17y squared is 1. Amazing stuff. Whether or not you spot that it's related, you might just try small numbers. That's something that's almost always available to you in these big general questions. General in the sense that it's got numbers in, variables in. General that might have some solutions for specific numbers or might not, might be true or false for specific numbers. You can just try some small numbers to try and build intuition about what's going on. Here, I think I want to try x squared has got to be quite a lot larger than y squared, so I want to try small numbers, so like 1 and 2, but 4 take away 17 is minus 13. 1 take away 17 is minus 16. So I could maybe start there and hope that things get better. I guess maybe I'll go higher, so 9 take away 17 is minus 8. 9 take away 4. And then maybe I get up to 4 squared is 16. And it's at 16 that things get interesting because this thing is minus 1. And then I've got an idea, but maybe you've got the same idea too. Ooh, x squared minus 1 is 17y squared. Can you then consider factors? It's tricky, isn't it? You've got a factor of 17. which I think, because that's prime, tells you that x is either 1 more or 1 less than a multiple of 17, can you then follow through and say that check x equals 16? See if that works. It's possible that works. 17 times 15. Problem is that 15 is not a square number, so you've got to keep going. Look at the next multiple of 17 or something. Yeah, 16 and 17 are only 1 apart. So this gives us some method here where we go x squared minus 17y squared is minus 1. So then my plan is that if I call that z, what I really want is z squared. I really want something else squared that's equal to like z squared. I want, instead of minus 1, I want 1 on the right hand side. And the observation or something is to use the same steps as what we were doing before. Thank you in chat. Same steps as what we were doing before to get from, well, up there we were trying to get from -2 to 4 and then we divided. In here I just want to get from -1 to 1. So I want some sort of fact. Oh, it's just off the screen, isn't it? There it is. I want some sort of fact with a z squared on the right hand side. I don't want -1, I want 1. All I need is some expression that's equal to z squared with 17s instead of 19s. So I need some sort of version of the thing in part 1, but with 17s instead of 19s. And then I'm exploring. Then I'm checking whether this works or not. But in fact, if you just replace these, it's silly there's an n here, but if you replace these 19s with 17s, everything works out. Everything works out just fine. And you get some expressions. Which say that you should take x squared plus 17y squared and 2 times x times y, and then you're just good. So what do I end up with? 2 times x times y is 8, and 4 squared plus 17 times y squared is 16 plus 17 is 33. So I believe that's true. Happy to be corrected because my calculations have not been great tonight. Yeah, 17 should divide x squared minus 1. Quotient should be squared equals y squared. I think that sort of works. If you check multiples of 17 for x plus 1, then you check 17 and then you check 34. Once you've checked 34, you discover this solution on the board. So you can do this by sort of other methods. Let's talk about this other method. I've got down to this solution for z squared, which I say is just by replacing all the 19s with 17s. There's this other method that's being discussed in chat, where you say that this looks like this, which says that this is 17y squared. So this is a multiple of 17, which is weird. How is it a multiple of 17? Well, maybe x minus 1 is a multiple of 17. Or x plus 1 is a multiple of 17. And that's not many things to check. So you might check 16. You might check over here, you might check x is 18. Over here you might check x is 33. And then you're done, because 33 works. So you might check sort of some numbers. That's a bit slower, I think. Maybe it's fewer ideas, but more calculation, because along the way you've got to work out 18 squared or something, right? You've got to check, if I put 18 in here, I get 17 times 19, and 19 is not square. Okay, maybe that's easy. And then you plug in 33, and you say, that gives me 2 times 17 over here. It's a little bit fiddly. 2 times 17 in here, and over here I get 32, and luckily 32 times 2 is a square number. You've got to track all the factors of 2. Oh, Rex says something relating together 17 and 19. That's a good observation. Explore in that direction. That sounds fun. Do that. Yes. Ah, yeah, can you set this up by doing... That's a good suggestion. Maybe you can. If you start at 1, 0 for x and y, and you apply this method, then you discover the next thing you find is x squared. No, so then the repeating thing gives you, unfortunately gives you, if you do this kind of process, it gives you 1, 0 back again. Because if you plug in y equals 0, then you get 0 here, snooze. and you get 0 in here as well, which kind of returns you to 1, 0. So that solution gives you trivial solution again. Oh, disappointing. But the non-trivial solution 4, 1 gives you this solution. You can then generate more, because once you found 1, you can keep doing the squaring trick to find more. Right, fun. Okay, I think we've talked about how you might have ideas along the way about what's going on. There's obviously lots of other things you might have ideas about. Maybe you spotted that 170 is relevant up here. Third colour, I think. 170 is relevant around here. There's some factors of 170. And this part of the question is about 17. So maybe you spotted that there's some sort of 17s going on. So maybe you can draw a link between those 17s in the question so far to help you with the 17 down here. And I don't know if that works. It's not obvious to me that it doesn't work, so maybe it's something to try. There's probably other approaches as well. Why did you choose 17, says chat. Do you mean, what level are we working at here? It's 17 in the question for a complicated reason to do with Pell's equation. It's 17 circled up here because I'm looking for other 17s, looking for other relationships with the one printed in the question. I should maybe not have admitted that I was involved in writing this question, because now I don't know whether the questions are based on me setting it or me doing it just now. It's embarrassing that I wasn't faster at doing it. Well, no, it's not. Live stream is not entirely about doing things at speed. Someone in chat said they want to see a sort of speed run where we try and do something at speed. Let's take a quick break. It's 6 o'clock. Remember to look away from the screen. If you've been looking at a screen for an hour, I'm going to drink some water. If you'd like to see me doing maths quickly, I had a go at doing a senior maths challenge quickly on a personal project. So I do Twitch streaming on Sundays, and I had a go at doing senior maths challenge fast-ish with help. People helped, but I tried to do senior maths challenge. So if you want that kind of silly content, then not on this show, because this is all about the map that you're doing in 2 weeks' time. But I separately do a Twitch stream where we do silly things. The mug is covered in tangrams. Tangrams are an ancient puzzle form. It's a puzzle with 7 pieces and lots of solutions. You put the 7 pieces together to make different shapes. Tangrams. That word is a little bit like anagram, but with a T. Anonymous, we're live 2 o'clock on Sundays. Thanks for asking. Yes, that's right. This is an official Oxford event where I am promoting a Twitch stream. Let's move on. Do I talk about college maths? Sometimes. Try to learn some university stuff. Right, good. Might be cooked for the mat. Chat, any advice? Method of boosting problem solving skills in 2 weeks. Well, I don't know about in 2 weeks, because you've been doing stuff. I think I've seen you here in chat before. I think you're going to try some more questions and get stuck on them. And then during the test, you're going to try some questions and get stuck on them, because that's just what happens with tricky questions, isn't it? And you're going to just lock it in, says user in chat. Right, okay. Thanks for the break. Should we do some more maths? Let's do some more maths. We could do the poll again. I saw question 3 did quite well in the poll. I don't know what to do though. They're kind of in order. I heard what Sophie said about seeing the questions in order. Lots of people have voted for question 1G, which is a cheeky thing to vote for, because we already did that one. That's the one you vote for. It's just somebody summarised my advice in chat as just practice, but unfortunately it is one of those things where if you've solved some problems, then your brain starts getting better at spotting ways to get out of a tricky situation. There are some votes for probability, and I think I advertised this, so I think I'm going to overrule democracy a little bit. We're going to come back to the democratically selected option. Yeah, you can see the voting up. Come back to the democratically selected option in a mo. Should we talk about probability? I just want to try and reassure people about probability. This question is about probability, and it's about as much probability, I think, as math questions can possibly have. You see, we have combinations on the math syllabus, which people sometimes ask about because they're nervous about the amount of probability that we're assuming. It's this much. And this question is mostly about counting the kind of binomial, almost like a binomial expansion of what can possibly happen. So we expect you to know how to calculate the probability that exactly 4 out of 5 coin flips come up heads. How does this question actually work? You just look at the cases, right? Oh, Alice wins if strictly more of her coins land on heads than Bob's coins do. I see they each have 5 coins. Sorry, there's not 5 flips total. They're both in a flipping competition where you must flip 5 coins. I see. So there's a draw. There's some chance that Alice wins and some chance that Bob wins. The game is fair, so probability Alice wins and the probability Bob wins are the same. So we just need to work out the probability of a draw, and then we're okay. So I suppose it's really about working out the probability of a draw. And then the other cases where it's not a draw seem pretty fair to me. Yeah, there's no advantage to Alice for going first. It's not even obvious that Alice is going first. Okay, good. Yeah, I've been distracted by the question. Yeah, Alice and Bob are in this, but Charlie is not. Charlie is not being called upon to do any coin flipping. Probably after the debacle with the cake from the previous year, of course. Where the previous year, yeah, we didn't talk about it, but Charlie is trying to cut a cake, and the joke in this question was that Charlie is doing a bad job of cutting the cake. They are aiming for quarters, area 1, but they've kind of missed the middle, so they can try and fix it by making the second cut a bit wonky to try and make it a quarter of the cake. So there's a question with just Charlie in from the previous year. This year, Alice and Bob. Lots of past questions have got Alice, Bob and Charlie in, especially the truth and lie sort of ones where maybe they're all wearing hats. Right, yes. Charlie is not excluded, but they know what they did. Okay, votes for 3 and 4 in chat, I think there. But we are going to talk about, I think we're going to talk about question 1 or something. Yeah, so Hannah's right in chat, there it is. If you swap Alice and Bob around, none of their question changes. You have to read it twice, I think, to work out. Yeah, you could just switch Alice and Bob, so it's kind of fair. So P1 is equal to, what's the question? It didn't even say P3, but 1 minus P1 minus P2 or something is Bob wins. It's like equal to P1. If it's not, yeah. If it's not Alice wins and it's not a draw, then Bob wins, but that's got the same probability as Alice winning. Good, okay, which gives us some fact. We could maybe analyse whether it's true that 2 times P1 plus P2 is genuinely equal to 1. I think it is in most of these cases. What is that, 2 times P1? It's not quite true, is it? There's something missing. 6, 3, what am I doing? I don't know what I'm doing. Oh, there's a factor of 512 down here. These things should add up to 256 in the top, and I think they do annoyingly add up to 256 in all of the cases. It's a shame. Okay, not enough. We also have to work out the, yes, probability that it's a draw. Yeah, what is that? So it's not just 5 choose 3, 5 choose 4, 5 choose 5, because Bob might get lots of Bob might, in the 5 choose 3 case for Alice, you're thinking about Alice flipping exactly 3 heads. 5 shoots 3, which 3 of the 5? But of course, some of those cases, Bob pulls out an amazing run and gets 4 or 5. So Alice doesn't actually win in some of those cases. So that's going to be too much, I think. Instead, we should be thinking about the probability there that sort of Alice, maybe 5 shoots 3 if I'm using your notation in chat, 5 shoots 3 for Alice getting 3. And also at the same time, I want to know about Bob losing. So I want to know about Bob getting not very many, which there's lots of ways for Bob to get not very many. But then also I want kind of other cases for Alice, the story where Alice wins with, the story with Alice winning with 2, or Alice even winning with just 1. Just 1, because Bob's had a terrible day. But Alice doesn't actually need to win most of the flips. Alice just needs to beat Bob. It's actually easier to work out the probability of a draw. There's fewer cases going on. There's fewer ways to draw than there are to win. A draw happens if Alice gets 0 and Bob gets 0. Or the other similar cases where they both get 1, they both get 2, they both get 3, they both get 4, or they both get 5. I should be dividing these, of course, dividing these by the total number of outcomes, which is something like 2 to the 5 times 2 to the 5 or something. That doesn't look very fun to work out, so I'll leave it to you. Anonymous feels sorry for Charlie. Don't worry. I can't remember if Charlie comes back in 2023 or even 2022. Is Charlie in this one? Are they selecting numbers later on? Are they eating lots of sweets? No, that was other people. Yes, there we go. Look at all that. There's a big sequence of stuff going on in chat. Yes. There's lots of possibilities. If you want to explain how Alice wins, there's loads of cases. 5-4, 5-3, 5-2, 5-1, 5-0. The probability of each of these outcomes. But there's not that many down the diagonal where they draw. I'm thinking about sort of this table of Alice and Bob. They get 0, 1, 2, 3, 4, 5 for the outcomes. There's kind of this observation that the ones where Bob wins are over here. The ones where Alice wins in the table are over here. And the draws are down the middle. So first observation is that this table is symmetric, and the probabilities over here and the probabilities over there will end up summing to the same total. And then the next observation is there's not very many things down the diagonal for the draws. So we should try and sum those rather than trying to sum the 15 things over here. 15? Yeah, 15. No comment, of course, about whether Charlie is in that 2024. Okay. Do I think that practicing typing fast would be a good method at the same time? Not really. I think you'll spend more time thinking about what you want to type and less time, by a significant factor, actually typing it. Because I think you're going to spend time being stuck and thinking of what to do. Sorry, but that's how math questions usually work anyway. You might do some scribbling on rough paper or whiteboard stuff about what you're thinking about before you decide what to write, but then actually typing it, I think, won't be. I'm not expecting people to type very much. Well, I'm not expecting people to type essays, right? Long text. Yes, work out when they draw. Yes. I don't know about the factors of 2. Yeah, something like this. All over 2 to the 10. That's what I've got, like all over 2 to the 10. Probability of them winning is equal. Yeah. 1 minus 2 is 2p1. Actually, once you've done this draw probability, that's called P2. So you just look it up. You just choose your option based on that one. It's cheeky, but P2 is different in all of these cases. So just select the one that matches your drawing probability. I can't remember which one it is. Don't really care. Okay. Can we get all points about type 2 sentences on complete English sentences? You're not being assessed on your English language for this. If you type in a legible manner, then that's probably a good idea. but you're not going to get marks down for like your use of full stops and commas or something. Sentence fragment, consider revising. You'll be marked about whether your explanation works. Personally, I think explanations work better if they're in full sentences, but I think we're going to see a bit of both. Yeah. Scared to come back to we decided to come back to the question later. Alright, where did the draw probability come from? I thought about all the different ways that a draw could happen. I thought about all of the ways that, for example, if a draw happens, maybe it's because Alice has flipped 2 heads and so has Bob. And there's quite a lot of ways that that can happen. Alice has got 5 coins to flip. Who knows which 2 of them came up heads. It's not impossible. In fact, there are 10 different ways that that could happen for Alice to score 2. And similarly, there are 10 different ways that Bob can win. Bob can score, 10 different ways that Bob can flip 2 heads. So the kind of combination is then 100 ways that we could see the 2-all tie out of the possibilities of 1,024, what's 2 to the power of 10? 1,024 different total things that might have happened, thinking about the narrative of as they do these 5 coin flips. 1,024 things that might happen, of which 100 end up with them on a 2-2 tie. And then the other terms come from thinking about other ties, including this one down the end, and it is just one amazing case out of the 1,024 possibilities where Alice and Bob step up to the competition. They have 5 coins to flip each, and one by one they both flip 5 heads in a row. Crowd goes wild. It's a tie, high scoring round. That is 1 in 1,024. Equally likely down the other end, they both completely fail to flip any heads, and it is declared 0-0 draw. Good. Okay. Am I going to go through MAT 24 the day after? No. We have a stream scheduled for 2 weeks after. Once the dust has settled, or whatever you want to say. 2 weeks after, we're going to do a special live stream talking about MAT 24. Not the day after, gosh. Spelling error is probably fine, so long as we know what you mean, I guess. You're not being marked on your spelling. If you're talking about things in the question, you'll be able to see them in the question, of course, right? Right, okay. Yeah, whatever species of maths you're applying for, whatever course you're doing, everyone's doing the same. Everyone's attempting all of the questions. Practical advice for you going into the test: you're going to be showing 27 questions and you're going to have a go at least 27 questions. You will not be shown any questions that you should not try. Okay. A timeline question from Matthew. When do we find out what score we got? You get an email in January as part of the feedback process. People get an automatic email with their MAT score. It is buried a little bit. It says if you don't want to know what your MAT score is, do not scroll down, and then if you scroll down, you can see your MAT score. We send those out automatically, so that you don't have to ask for it. Okay, let's have a look at question 3, but let's try and pick out the important parts of question 3, if you like. I'm going to assume you can do this sketching of a quadratic and a degree 4 polynomial and a degree 6 polynomial, so that's kind of fun. Let's have a go at that quickly. X squared minus 1, but then square it. Oh, that's nice. What's this? To the power of 3? You've got, this to the power of 3 is going to be like that, because I'm going to sort of take this as a negative, but kind of bit things near 0 to the power of 3, get very near 0. Yeah. Or do I get them? Oh, I get the MAT scores. Yeah. Oxford gets the MAT scores not immediately. We have to go and mark it, but once we've marked it, we've got the MAT scores. We use it as part of our shortlisting when we're deciding who to interview. So we get it pretty soon afterwards. Will you tell UCAS no, or our school no? No. Data protection. We won't tell anyone. Okay. Without calculating the integral explicitly, explain why there is no positive value of a, such that this thing is 0 if n is even. Goodness me. I suppose if n is even, then what I'm thinking is that the power is even. I should look at where is the n. There it is. Where's Wally, right? Where's the thing? Find Z, there it is. Find N, here it is. If the power is even, then this thing looks positive because it's a sort of squarey sort of thing. I just had this idea that squaring up here made it positive, so I was already thinking about squaring making stuff positive. I guess if N is 4, then power of 4 also going to be positive numbers. Oh, x squared minus 1 is greater than or equal to 0, so the integral is greater than or equal to 0. I would write that out with more words. I am scribbling in a small amount of space. The feedback is that you get your MAT score. You get your score. There is a wider feedback process for admissions, if that's what you mean. You can, if you do a quick search for Oxford admissions feedback process, then you should find the page that explains how the feedback process works. You don't have to ask for feedback if you don't want to. Most people don't. Right, this is fun. We're now getting the sort of questions that are about the MAT rather than being about this MAT, which is where I'm going to try and move us back. Hopefully you can get your candidate number in the Pearson View. Hopefully you can get that in the Pearson View portal where you registered for the test and booked a slot. Get your candidate number in there. Yeah, okay. If N is odd, we're going to write this and we're going to find AM. We've just got a subject on it. Oh, I see. The idea is that if N is odd, then hey, maybe this thing is 0. We just said that it's, if N is even, then it's not 0. Doesn't happen. If N is odd, then maybe it does. Explain why this exists. So I suppose I have an odd picture up here to think about this integral. I should think about how integration represents the area almost, plus and minus signs. It's going to be negative, isn't it? If AM is over here, there's some area down here, but the integral will be negative. And then there's a bit over here where the integral over this region might be positive, and maybe they'll balance each other out. Maybe if I make AM large enough, this thing will go positive. So I'm kind of traveling through the question, bringing ideas through. So here I had this kind of evenness of, I'm thinking about the pictures, and then I'm thinking about 0 integral, and I'm thinking, would the integral of this be 0? Well, no, the integral of this would obviously be a positive area underneath, right? So positive area means non-zero. So not 0 because it's positive. So I'm having this positive idea, and then in here, I'm thinking about the areas. Well, now it's not so clear because there's some negative area and there's some positive area. So I should look at the kind of balance between negative and positive. Then some actual calculation. Go and do some stuff, which I think you do just by integrating. I will take suggestions from chat about whether or not. Oh, Ali got a reply from Callie. Let's see, that's a very good thing. Callie is being reassuring and encouraging in chat. Yeah. Thank you, Callie. Yeah. What is going on? Find the approximate value of AM when M is a very large positive number. You may use the fact that if you get to root 2, then this integral is negative for any sufficiently large. What's special about root 2? Oh, I see. Okay, so root 2 is the point where the value of this function. Oh, I had to label any points that were on both curves. I ignored that, but that would have made me think about how root 2 is interesting, because when you put root 2 in, you get the number 1, because root 2 squared is 2, take away 1 is 1, and then no matter what the value of n is, you always get 1. So if I'd paid attention to the question up here on both curves, I would now be thinking about what's going on with root 2. Okay. That's negative, but then after that, the value is then extremely positive extremely quickly. So I think we might end up being about root 2. Okay, Anonymous says in chat, general thought was to see where the y-intercept was, see what area it could create, moving outwards from the y-axis. Yeah, okay. So yeah, there's the the things that I'm trying to shade up here, I guess, are those areas as you change AM to try and find out, is this true or not? Does this happen? As you move AM, is it supposed to be close to 0? Is it supposed to be far away from 0? What sort of number am I looking for? It's something to do with this area, this kind of region underneath the curve in some sense. I'm saying in some sense there because I'm trying to remember that when you integrate, you might get a positive number or a negative number, or in cases like this where the function crosses the x-axis, you get some positive quantity and some negative quantity added together, whereas area is a positive quantity. So if we were actually talking about the, strictly speaking, actually area, we'd have to split it up, because that's a thing that other math questions have made me do. So I suppose the experience point here is that thinking about integration for a function that crosses the x-axis, a little part of my brain is maybe thinking, should split that up and think about positive and negative quantities. And in this question, you don't actually have to calculate them. You do later on, but in part 3, you don't actually have to calculate them, you just have to think about how they exist and how they could balance things out. Yeah, it's been a while since anybody tried to talk about burritos, hasn't it? Hasta luego, burrito man. I miss them too. Right, okay. What are we up to? We've had a quick look at question 3. We've tried to pick out the key concepts in question 3. I haven't done the integration down here. I sort of don't want to. I mean, I probably could if I had to. Probably you can work out this integral when m is 1 or 2. If it's 1, that's just a quadratic, right? If it's 1, this is just the question x squared minus 1. 2 times 1 is 2, minus 1 is 1. Not a trick question. x3 minus x, a1, 0. So this is just a question about solving this equation. So is this thing 0? We would like this integral to be 0. I guess obviously that happens when a1 is 0, but then there's a quadratic to go through here in terms of root 3. Well, maybe it's true that they keep decreasing. That could be true. It's not obvious. Yeah, I don't know if that's true or not. It could be true that these values keep decreasing, because I think this one's going to turn out to be root 3. If I set this expression equal to 0, you've got the 0 root, and then you've got a quadratic involving 3. So I think this might be root 3. And then this proof down here is going to be to prove that a2 is less. I still want to calculate it though. I still want to go x squared minus 1. So if I put in 2 up here, 2 times 2 is 4, minus 1 is 3, quick maths. And then I've got to do some work here. I've got to do some serious work here, haven't I? If I plugged that in correctly, yes I have. Got to do some serious work. If I do that, then yeah, no, I think the idea here might just be to calculate. I can do that integral. And then I'll plug in root 2 and root 3 and check that it changes sign. I'll get some expression, right? And we're looking for a root of a polynomial. And you know lots of stuff about finding roots of a polynomial. Maybe you don't realise that you're finding roots of a polynomial until you've done the integral. But once you've done the integral, you get over here, that's a polynomial. I'm going to get another one, degree 7 or something horrible, but I'm going to get another polynomial. And this question is about roots of polynomial. Roots of polynomials, really. Here it's telling us to find this root. Here it's telling us to talk about one of the roots. I can talk about roots of a polynomial by remembering about sign changes. Yeah, expand it and use substitution. I'm too lazy right now to actually go and do that, but I'm going to say I'm pretty sure that works, which I think is the aim of this bit. Right, so, okay, what does chat say? Chat's talking about expanding it and substituting things. And there is a pending question, which we're going to put in, but it is also about starting mat prep now. So really glad you found the live stream. Hello, welcome to the show. We're just doing past mat questions. We've been doing it for a while, but the thing we're really trying to get better at is being stuck on problems. Look at me backing away from it. Like, oh, this looked quite tricky. Let's just walk away from it. The best way to practice is to not walk away from it and just try and calculate it and keep exploring. See what happens. If you actually do that, does it work out? Something for you to try. Substitution isn't on the syllabus. I think, oh, right, I know what they mean. Oh gosh, do they mean integration by substitution? I would not integrate this by substitution. My word. Is it nice? No. Integration by substitution is not on the MAT syllabus. I would just go for it here. The substitution x squared here will, I fear that will not help you. So then you've tried to use a technique that's not on the syllabus and it's not helped. I kind of feel like that will happen sometimes. Yeah, because if you want to do x squared, hang on, I don't want to panic anyone, but I'm going to briefly talk about maths that's not on the syllabus. I think the suggestion in chat is that you try u equals x squared, possibly u equals x squared minus 1, but then you've got to deal with the fact that you don't have 2x dx, you just have dx, so that'll be divided by u squared plus 1 or something. That's a nightmare. That's not what you wanted. Or root u or something. But it's still got a minus 1 in. Yeah, I can't really see how to make that better. You're still going to multiply a cube or deal with something being divided by root u plus 1. Yeah, not a good sub, I think, the one I'm talking about. Expanding it is a better method. Thank you, chat. Actually, don't feel like I'll be able to do or even understand the long questions. We could probably get started with one. For example, this past question just talks about sketching this curve. So often the first part of it, look, this one wants you to just sketch a curve as well. Just the first part of this, given increasing certain way, okay, you have to read these 2 paragraphs to work out how to do the first part of this question, so maybe there is a bit of an understanding task there, but yeah. Not the chain rule. It's not the chain rule, because there's no 2x dx in front of it. It looks like it's almost doable, but it's not. I think you've got to multiply it out. Chain rule is also not on the math syllabus. Yeah, there's no CS questions this year, so I just put one on screen. Oh no, I didn't. I put question 5 on screen. There's no CS questions this year. Everyone's doing the same questions as each other. Okay. Yeah, we're not going to sketch when it's on computer. Okay. We're looking at past question. No one is saying that past questions will necessarily work in the current setup for Mat 24. It's nice looking at them though, isn't it? Okay. Use complex numbers on the syllabus. I love them. Chat, I know you love complex numbers. There are no complex numbers on the syllabus for math questions, which means that the questions are written without assuming you know about complex numbers. It's very unusual for you to be able to use complex numbers to do anything in a question, and in fact you can make your life a lot worse if you insist on using complex numbers. Right, okay, let's put the poll back on. What are we doing next? I had a quick look at question 3. I decided I didn't want to do most of question 3, or slightly more pretentious take, I decided it wouldn't be useful to do question 3 on screen. We've got half an hour here. Let's do a different question. Should I delete question 3? Is that cheeky? Can I delete question 3? I can. Oh no, I can't. I can change it. I can change the option. That's fun. I can rename it. Don't like that. Yeah, so this chat says, how do you write integrals on a keyboard? And great news, there's no integral button on a keyboard. There is no obvious way to write integrals on keyboard. The people writing the questions know that. You are not expected to type complex mathematical expressions during the typing bit of the MAT 2024. Do I know why it's now mandatory for you to apply to Oxford to take the maths? Yes. Given it's not the same for Tamua and STEP for Cambridge. So observation. Tamua and STEP are quite different exams from each other and from MAT. There's lots of differences, and some of them are important differences. Good, okay. somebody in chat is pretending that they integrate functions like x squared using complex numbers, which, you know, they're welcome to try. Chat's voting a little bit for 1J and quite a lot for question 4. How much do I want to do question 4? A little bit. A lot of graph transformations in question 4. I could imagine things like this turning up in a multiple choice question in the future. It's not just long questions typing answers in boxes. We've also got we've also got multiple choice questions, which can get you to do something a bit like graph sketching, of course, because a multiple choice question could say something like, which one of these is the graph of this function, which is then just like a graph sketching question, except multiple choice. So we'll still do similar things. Okay, bit of voting happening. I see the voting. I'm switching it off again so that I can put chat on the screen. But we're looking at question 4 and then a bit of 1J, I think. Okay, good. So this question wants us to do a graph sketch. I mean, it's sort of root x, which looks like this. It's more like a circle. Root x, which sort of grows, very sharp over here, minus x over 4. Observation, if x is sort of 1,000,000 or something, if it's very large, then this thing is about 1,000,000, whereas root x is much smaller, it's only about 1,000. If you put a large number in, you get something very negative, even though this is divided by 4. Like this, I guess. I guess I could think about, I'm saying guess a lot. I could think about when this is equal to 0. The question wants me to find the turning points, for which I suppose I will need to differentiate. Ooh. And solve some sort of equation. That turns out to have solution 4, what's the value when x is 4? 2 take away 1 is 1. 4, 1. And then over here, this thing I think has solution 16. So it goes through 16 on the x-axis. Origin is where it crosses the y-axis. And its turning point is at 4, 1, I think. There was a hidden quadratic there, wasn't there? Secretly, that thing there is a quadratic equation in the square root of x. Is that helpful? Not sure. Alternatively, you can just divide by root x without thinking any quadratic thoughts. But if you're into quadratics, then you can find some of those hiding around here. Question, log base p is 36, log base q is 16, log base pqr of s is 8. What's log base r of s? For that one, I think I would undo all the logarithms, write down some equations. Log base q if s is 16, so yeah, write down some equations. S is p to the 36, it's also q to the 16. So yeah. Oh, it's a Tamua question. There you go. I would turn the first two into statements for P relating to the P and S and Q and S. And then, well, I'm laughing all the way through, not laughing, what's the phrase? I'm laughing all the way to the bank. Is that a phrase? Is that a thing people say? That's in my head for some reason, because now I'm going to take the last one and work out a relationship between R and S. The thing in chat wants me to talk about how P to the 36 is S. I hope I'm getting my logarithm facts right. It'll be embarrassing if I don't. PQR to the 8 is equal to S as well. Well, can you find a way to relate these things together? I'm probably going to try and eliminate P's and eliminate Q's, because the thing I'm aiming for is relating R's and S's together. So what's this? 36 is not a multiple of 8, is it? 4.5 or something. 4.5 eighths. Don't like that. S to the 1 over 4.5. Oh, to the 8 afterwards? Oh my god, okay, right, fine. Plug two of them into the other one, rearrange it. Was that really a Tamua question? Oh, okay. Yeah. Oh, somebody else in chat's doing something great. Well, careful. I think they're basting... Goodness knows. I interpreted that underscore to mean one particular thing. Somebody else has interpreted their underscore to mean something else. Good luck, everybody. Oh, and if you know a log fact, it's easy. Oh, I don't like that. Yeah, I don't like that at all. Right, let's do some graph transformations. Describe in words, in words, how the graph of this is related to the graph that you sketched in part I. What graph transformations have happened? That's kind of a part of this where the x seems to have been replaced by 4x plus 1. I can think of a couple of ways to achieve that. And also this bit has been replaced, x over 4 is now minus x minus 1. I can think of a couple of ways of achieving that as well. I suppose one thing I want to try is replacing x by 4x, to see what that does. And then I'll stop and think and see if I can do some sort of translation afterwards. I'm thinking translation because that will shift around this bit and it will shift around that bit. Maybe I want to do a translation up and down as well, maybe not. But I think my strategy for that is the factors of 4 have moved around, deal with that first. And then there's something going on with the translation to shift around these values of x. Live stream started 100 minutes ago. It does feel like it's been a long time, so thanks. Some of them fly by, some of them I really feel like I end up 2 hours older than I was when I started. Right, transformations, let's go. So something like, what is the transformation that replaces x with 4x? What is that? That's a stretch, isn't it? Parallel to the x-axis, maybe by a factor of 1/4, because the x-axis is treacherous. It's the one where it's the other way round to what I thought it was. That would give me something like y is root 4x minus x as a graph. Let's just think. That is a squash by a factor of 4, which would move the turning point of 1, 1. So I could do a quick sanity check to make sure that when I differentiate that, I do get a turning point at 1, 1. To make sure that I've got the squash the right way around. See, good to do a little check to make sure that things make sense afterwards. Good. Glad that I was going to say glad that someone's enjoying it, but I'm having fun too. Okay, we've got some sort of squash, and then I might do something like, I kind of want to change this x into a. This is a bit awkward, isn't it? But like x plus a quarter, which is a translation by 1/4 of a unit to the left, because the x-axis is treacherous when it comes to transformations. It's the one with division and minus signs in it. Translations parallel to the y-axis, they do the thing that I think they do, like adding 1 means you went up. Translations parallel to the x-axis, I've learnt that that one is the other way around. Yes. Good. People in different time zones. Yeah, there's a lot of test security stuff going on. I am limited on how much I'm allowed to say about test security measures, but please can we be assured that there is test security stuff going on. That means that although it's true, as it has been in previous years, that people in different time zones start the test at different times, that there is test security measures to prevent that from being an issue. That's for the anonymous person in chat, really. Yeah, how do we know the order of transformations? Well, I'm doing them one at a time because I'm a bit tired and I can only think of one at a time. I'm doing them one at a time. I haven't got there yet because for me, I've just got as far as y is root 4x plus 1, which I'm happy with, minus x minus a quarter. That's what happens if I replace x with x plus a quarter, which is a translation to the left. And again, I could do another check here to make sure that it's got a turning point at, well, what's 1/4 left of whatever I said before. So I guess I'm now at 3/4, 1. But it's not quite over. I want to do a bit of subtraction. I've got minus 1/4, I want minus 1. So I want to bring down the y coordinate. Okay. I've got 3 transformations going on. Maybe at home you've managed to do this in 2 transformations. For me, this is a par 3. I think 3 transformations is reasonable. Possibly someone at home has got a par 2. You got it in 2 transformations by combining some translations. I don't know. Or maybe the sequencing the other way around is better. In the longer questions, if you answer the question correctly without explaining, really want to stress that the long questions you should expect to explain and justify. And that if the question says explain or justify, then you must explain or justify. And if the question says explain or justify and you don't do any explaining or justification, you should not expect to get very many marks for that bit of the question. Yeah, good, okay. So people are worried about test security, which is, I suppose, you have the right to be worried. They're in Pearson test centres. So there is actually, compared to previous years, I think more security than we've ever had on the test, because it's now in these kind of independent third-party Pearson VUE test centres with that level of invigilation. So I'm sort of happy about that. Somebody in chat's doing the next part of the question. Let's go with that. Talking about Pythagoras, which seems like a good idea. Yes, they have strong opinions on what distance is, which is good. I like that. Length of AP, the distance from P to A, multiplied by the distance from P to B is 1. Yes, multiplied, that's what this means. Yes, good, is 1. That 1 is what 1 means. Good, good, good. I think I've understood. Find all points that lie on both the x-axis and also on the curve C, which is a little bit tricky because you want to do something like x plus 1, but these like absolute value signs for the distance. And then BP, you want to do something like x minus 1 for the distance there. Maybe it's a good idea to write down the full Pythagoras thing for what's going on in general, but you know, could do some full Pythagoras. Should we do full Pythagoras? Never go fully Pythagoras, but you know, here we are. So I guess AP is the distance from a point P, which I'm going to say has coordinates x, y. Have I got that point P? Oh, never mind. If P is at x, y, then we know that the distance to A is this, the distance to B is this, and the product of those things is supposed to be 1. So fairly standard trick, I suppose, is to square both sides, or to say it's usually easier to work with distance squared, to work with c squared rather than a squared plus b squared rooted. You know, we've got those. The Tamua question at the top there. Tamua and Matt are set by completely different people. There's no reason to think that they would be related in terms of content. Okay, Pythagoras time. These things are multiplied together. I think I should square them. I've got a feeling I want to sort of rearrange this for y. Yeah, this is not too bad. This looks a bit like a quadratic or something, right? You know, if I want y, then I'd be reasonably happy with having y squared. How am I going to get y squared out of this? It appears twice in the equation, which is making me think quadratic, right? If something appears twice in there. I mean, it sort of appears 4 times because y appears twice in the y squared on the left, twice in the y squared on the right. There's kind of 4 of them, but they're paired together. So if I aim to get y squared, then, well, that appears twice. So I'm thinking quadratic, really. Is that a bit optimistic? Let's give it a go, see what happens. So we're going to try and determine a function f of x for y. Who made that? If I multiply this out, and I'm not just randomly multiplying it out, you might have noticed I stopped and thought for quite a long time before multiplying it out. I'm aiming to try and get this to look like a quadratic for y squared. I'm trying to solve for y, I think. I want y equals f of x, where all the x stuff is on the right-hand side. So I'm trying, I'm multiplying out quite slowly to see if I can make that happen. Oh, this is not too bad. This will give me plus 2x here, but then minus 2x there. So that's not too bad. And this will give me x squared minus 1, difference of 2 squared squared. I think I did that last week. That's not too bad either because the 1s are going to cancel. Move out the 2. That's a little bit fancy. I don't know if I needed to do that, but move out the factor of 2 because I'm trying to make this look like a quadratic for y squared. Why do I think y squared? Well, I suppose y only appears as y squareds, and again, maybe I'm reluctant to do anything with that. Just keep it as a square symbolically, like the 19 squared from earlier. To keep that as a square, unless I have to. Because look, like now I can do this kind of quadratic formula thing. Let's see, goodness knows what that is. Divided by 2, but cancel the 2 from here and here. I've done that thing. I've done this before. Sorry, where I've used a slightly different version of the quadratic formula than the one you learned, but pretty close to the one you learned, so I think we're okay. Oh, okay, so I've got minus x squared plus 1, plus or minus, x to the 4's cancel, and the x squared sum, there's 2x squareds in here, minus minus is 4x squareds, and there's a 1 here. And that looks quite similar to the thing we had before. So y squared is, I went plus or minus here, hard question. I feel like I want a plus sign because I want this to be positive, so that it's equal to y squared. Is that actually sensible? Does that actually make sense? I said it as if it makes sense, but no, I should probably go back and check. If I put a minus sign in here, oh, this is definitely negative. If with the minus sign and the x squared plus 1 stuff, so if I put a minus sign in here, I'm definitely going to get a negative quantity. Don't want that. I'm going to put a plus sign. Yeah, y squared is positive. Thank you, chat. Oh, multiply. Oh, multiply. Oh, you did some dividing. Ooh, dividing at this stage looks fun. Oh, if you divide at this stage, then you get exactly 1 on the left-hand side. Ah, but you don't get 1 on the right-hand side anymore. You have the option to do that. I didn't think of it, and I don't believe in, yeah. Is B in this quadratic? Oh, yeah. So, sorry, I've done that thing where I have all the factors of 2. I've done this a couple of times. Quick side note on quadratic formula. Okay, let's suppose that we're trying to solve this quadratic. I've seen this a few times as kind of the joke is, oh, watch out, there's a factor of 2 here. But if you play along and you say, right, okay, I'm not going to fall for that. I'm going to write this out to get 4b squared, because look, you're supposed to square the coefficient, not just blindly square the letter b. You square the coefficient, you get 4b squared minus 4ac, all divided by 2a. The nice thing is that then that simplifies a bit to give you this expression, which is just quite nice, and it's sort of almost worth remembering. I mean, what have I saved? By remembering that, I've saved myself from dividing by 2, top and bottom, which, I don't know. And I've introduced the possibility that I get any of these 3 things wrong, because this is like the quadratic formula, but not quite. But somehow, over the years, maybe, I've trained myself to very carefully write this down, so that if I see a quadratic where there's a factor of 2, I kind of saw it here, I see the factor of 2, and then I think, aha, let's see if I can write down the quadratic formula without writing any of the factors of 2 or 4. This thing becomes the letter B. So that's why I don't have a divided by 2, and I don't have a 2 here, and I don't have a 4 here, and I don't have a 4 here, because they've all cancelled. Gosh, everywhere. The 2 gets cancelled. Whether or not you want to learn that as a sort of slight variant quadratic formula is up to you. I don't know how helpful it is in life to have a slight variant quadratic formula, but that saves me a little bit. Hello again, Lewis Hamiltonian, welcome back. You're not 6 months old, you were on the live stream last year. Unless you were watching the live stream aged -6 months in utero. Right. What's the easiest way to revise or learn trig? Good news, for the MAT you don't need to know very much. For me, I've kind of got 2 triangles in mind. I've got this one. That's a terrible picture of a triangle. and this one, which I've drawn very different. Oh my goodness. You can get by a lot of math questions by remembering these two triangles and remembering what's going on in these two triangles. So I remember this one like that and this one like that, but that gives you a lot of values. There's a couple of facts about like the graphs of sine and cos, but trig is one of those things where you can build quite complicated things out of quite simple facts. Like if you need cos of 315 for some reason, you can just about work that out from what you know about values of cosine and the behavior of cosine. So maybe you remember that, cosine repeats every 360 degrees, and going right from one of those points is the same as going left from one of those points. It has this left-right symmetry about one of those lines. So this is the same thing as cos 45 over here as well. This one is the same as this one as well. You can sort of piece together this kind of building block where I can remember 1 over root 2 as the value of cos 45, and then I can remember some tricks to work out that it's the same. What do you get? In before somebody asked me for solutions to the 1379 math paper. Goodness me. We do a little trolling. How to work on geometry in the next 2 weeks. Geometry, bit harder. Here is a key calculation for you to practice if you want to do some geometry. I should finish the question, shouldn't I? Which is on geometry, really. So I'm going to do that. Here's a key calculation. Here's a circle, angle theta at the middle. If you draw in this chord, that's a word that you might need to know. Draw in this chord between these 2 points that lie exactly on the circle. Then you have, on the one hand, a sector of the circle, and you have on the other hand a triangle. You can find this area. And that's a good way to practice that you can remember how to find the area of a triangle given the radius of the circle, and that you can remember how large a sector of a circle is. And if you can work that out, then you can do some pretty fun calculations involving circles and triangles. Good, right, yes, I am trying my hardest, even though I'm a bit tired. It is 5 minutes to 7. Let's finish this question, and then I'm going home. What are we doing? Use part 2 to determine the coordinates for any turning points. So I suppose what we're being clued to do is to realise that before this paragraph, we were doing a different question entirely, where we were thinking about turning points of this, and now it's come up here with y squared and x squared instead of y and x. The big leap, I suppose, is to say, well, before the turning points was at blah blah, and now probably those are the values of y squared and x squared that we're interested in. Maybe that's a bit of a leap to say, oh, this looks the same but with y squared and x squared. So instead of the turning points being at those values, I should look at the square roots of those values. There's different ways you might think of that, I suppose. But in a way, you know which value of x squared to put in to maximize this function. You worked it out up here as being the value of x. Down here, you still know what number to put here and here. Okay, now it says x squared, but you know what number to put here and here to maximize that function. Maximizing that function still gives you a turning point. But here it's now labeled as x squared as the slot for where you can put a special number. So we're probably going to do square root, but that sort of thing. Good. Ah yes, it knows the area of a sector. Good. Minus the area of a triangle. Go for it. Good stuff. It does look like the equation in part 2. And we are told to use part 2, in case you hadn't spotted that it was the same. Maybe that's a clue as well, that if your algebra's gone a little bit wobbly in this part, it now says use part 2. How is this related to that? You've got to hope that you have something similar. It's another reason to take the plus sign, isn't it? Look, there's a plus sign in part 2, so sneakily, I'm hoping to get a plus sign for comparability with part 2. Make part 2 useful. Multiple choice is going to be worth 70 marks in total. I think we've published that. Oh, we've told you that there are 2 long questions worth 15 each. You know the whole thing's out of 100, so you can deduce there are 70 marks for multiple choice. Alien emoji. I'm going to stream on Twitch on Sunday. That's my schedule. Right, good. Okay. Thanks for getting me to advertise a Twitch stream again. Ha 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 ha. Giving Twitch a go. The idea there is that I'd like to talk about maths that isn't on the mat and talk about other stuff. And, do some fun maths with people. Again, right now we want to do math questions. We've got this sketch going on, which is going to be a bit related to this, and that will finish things off. Twitch is my outlet to talk about maths that's not related to the reason we're all here, right? Twitch gives me a chance to talk about something else. Right, so we previously on MAT Livestream, we had this function, which I guess is now 3D origin, I think, like this. -1/4? Maybe I shouldn't comment. Can I remember what the function looks like? No. After the transformations, does it go through the origin? Yes, because 1 take away 1 is still 0. Okay, it looks like this. But squash down a little bit. That's a function of y against x. Then we replace it with x squared, replace it with y squared. Thinking about y squared equals f of x means that we get this kind of plus or minus sign. We get only bits where this function is positive. Oh, I've got an equation down here, haven't we? We're sketching this. So if this right-hand side is not positive, then I'm not interested. It's kind of this thing for what's going on where y and x are both positive. And then the whole thing is quite symmetric. Left-right symmetric because a and b are symmetric, and up-down symmetric because distance works like that around both sides. So you end up with something that looks like this. And I think that's a nice place to leave my live stream for this week, with a question that gets you to draw, believe it or not, an infinity symbol, using just distances and equations. Right. Do I not think math is fun? Sometimes. Sometimes I think math is fun. How much did I score on the mat I took? Ha 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 ha. I've never done the mat. I just write some of it and do streams about it. No, sorry, I didn't go to Oxford. Right, good. Okay, have a nice afternoon. Enjoy your evening. We're going to be back in 166 hours. 166 episodes? 166 hours for one more episode of the MAT live stream before we switch to actually doing the test, I suppose. All the best with any revision or preparation you're doing. All the best with other maths that's going on. And we will see you. Yes, we can use an angle. Oh, right, okay. Question asked the number of roots. Distinct roots, yes. Number of roots means distinct roots. We try to say distinct whenever we remember. If we mean distinct, we try to say it. If we haven't said it, then I would probably assume that we meant to say it. But we will try very hard to say distinct whenever. Right, time to go home. We will see you in 166 hours. I've already said that. Take care, everyone. Have a good weekend. See you next week. Bye.